So here I just go through the component part. So here I train, initially, I load the MNIST dataset. So I show you a few characters here, okay? And I train now a multi-layer perceptron, like a fully connected network, like a fully connected network, and a convolutional neural net, which have the same number of parameters, okay? So these two models will have the same dimension in terms of if you save them, will weight the same. So I'm training here this guy here with the fully connected network. It takes a little bit of time, and he gets some 87%, okay? This is trained on classification of the MNIST digits from Jan. He actually downloads from his website, if you check. Anyhow, I train a convolutional neural net with the same number of parameters. What do you expect? To have a better or worse result? So my multi-layer perceptron gets 87%. What do we get with a convolutional net? Yes. Why? Okay, so what is the point here of using parameter sharing? What does it mean? Given that we have the same number of parameters, we managed to train much more filters, right, in the second case. Because in the first case, we use filters that are completely trying to get some dependencies between things that are further away with things that are close by. So they are completely wasted. Basically, they learn zero. Instead, in the convolutional net, I have all these parameters that are just concentrated for figuring out what is the relationship between neighboring pixels. All right, so now I take the pixels, I shake, everything just got scrambled. But I keep the same, I scramble the same way all the images. So I perform a random permutation, always the same random permutation of all my images, or the pixels of my images. What does it happen if I train both networks? So here I train, see, here I have my images, and here I just scramble with the same scrambling function all the pixels. I have my inputs are going to be these images here. The output is going to be still the class of the original. So this is a 4. You can't see? This is a 4. This is a 9. This is a 1. This is a 7. This is a 3. And this is a 4. So I keep the same labels, but I scramble the order of the pixels, and I perform the same scrambling every time. What do you expect as performance? Who's better? Who's working? Who's the same? Perceptron, how does it do with the perceptron? Does it see any difference? No, okay. So that guy, still 83. Jan's network? What do you guess? Oh. No, that's a fully connected, sorry. I'll change the order. Yeah, see? Okay, there you go. So I can't even show you this thing. All right, so the fully connected guy basically performs the same. The differences are just based on the random initialization. The convolutional net, which was winning by kind of large advantage before, actually performs kind of ish similarly. But I mean, much worse than before. Why does this happen? Right, because we don't have any more those properties applying, right?